Solids can precipitate from solution. In other words, sometimes, but not always, when we mix two aqueous solutions, a precipitate or a solid forms. Reactions in which this occurs are called precipitation reactions. An example of a precipitation reaction is the reaction of an aqueous solution of silver nitrate with an aqueous solution of sodium chloride. Both of these reactants are ionic compounds consisting of a cation and an anion, respectively. Keep in mind that in this type of reaction, the ionic compounds dissociate and then swap partners. We need to remember that anions always go with cations, so we take the anion from the first compound and pair it with the cation of the second. Then we'll repeat with the with the cation of the first and the anion of the second. We'll put these things together to form neutral compounds, electrostatically neutral compounds on the product side, ending up with AgCl in a 1-to-1 ratio and NaNO3 also in a 1-to-1 ratio. In this particular case, the silver chloride is the precipitate, or the solid that comes out of solution. A key concept in chemistry is that there must be a driving force for the chemical reaction to occur. In precipitation reactions, that driving force is the formation of the solid. In other types of reactions in this class, the driving force could be the formation of a liquid or a gas as well. In precipitation reactions, it's really important to remember that if no solid forms, then no reaction occurs. You'll see this come into play in several homework problems and things of that nature. Acid-base neutralization reactions work on the same principle of anions and cations swapping partners, the same idea that we looked at with our precipitation reactions. Both the acid and the base are composed of a cation and an anion, and we swap partners. In the acid-base reaction, however, one product always is water, at least until we get to 12-12 and start looking at weak acid, weak base reactions, while the other product is an ionic compound. In other words, we call this a salt. In the case of these acid-base neutralization reactions, the formation of liquid water is the driving force.